We're gonna get started. Hello, everyone. Welcome to HackCloud. This is our final session, which is awesome. Yeah, it's kind of crazy actually. The quarter's gone by so fast. Anyway, my name's Anar. That's Andy. We're covering data science today. Here's a link to the slides. Scan the QR code if you would like. Also, there should be something on Discord, a link if you want to check that out. Also, there's no candy today, unfortunately, because Andy forgot it, which is very sad. So I'm sorry about that. We will try to make it up to you by giving you an awesome workshop. Um, yeah, sorry about that. Okay, so today we're covering not data science. We are not covering data science. We decided that we want to do something more fun. So if you came here with the intention of learning about data science, I am so sorry. But we're doing something hopefully more fun. So yeah. Instead, we're doing something which I will let actually my friend Super Kai 64 introduce to you. So let's watch this video together.
Show this website.
I was wondering, what's the recommended amount of dedicated RAM I should have to serve? Dedicated RAM to a server. If you're running on a server.
Oh. I don't know, plugins later. Yeah, which really depends. Is it technical question?
Okay, that's enough of that. So yeah, we're covering today what is the recommended amount of dedicated WAM to server, or in other words, we're going to show you how to host a Minecraft server. Of course, using AWS because it would not be HackCloud if we're not using AWS. Do we actually recommend doing this? No, because there are probably better options that are maybe cheaper. I'm actually not sure, but they're just easier. But this should be fun, so we're gonna do it anyway. Yeah, so let's just do it. We're gonna use EC2 if you remember that back from like I think it's week 3 or 4, something like that. But yeah, let's just get into it. I'm gonna let Andy take it away. Ooh.
Hello, everybody. So, we had some mishaps during the actual workshop, so I'm re-recording this, so that we don't have to go through all of that. It was due to Docker, some weird stuff happened. But pretty much today, we'll again be making a Minecraft server with AWS, and you'll be using the official Minecraft servers to host using an EC2 instance. Which pretty much all we're going to be doing is we're going to create our instance, get our Minecraft server using Docker. Somebody's made this really awesome Docker container that will allow you to get a Minecraft server that's like up to date all the time, and you'll get logging and whatnot. So that's super helpful. This won't be too long of a workshop, and it's meant to be just more fun, practical application of what we've been learning so far throughout the year. But let's just get right into it. So here at the start, just make sure your region's what you want. I'm in North California, works for me. And if you go to services, we'll search for EC2. You can just click EC2. And if we go to this big orange button, launch instance, we're going to be making our EC2 instance. So for a name, it can be whatever you want. I'll name it Minecraft Demo, or actually, we'll make it shorter. This does not matter, but MC Demo. And for application and OS images, all you want here is you want to make sure you're familiar with your operating system or your distribution and its CLI or command line interface. We're going to be SSHing into this EC2 instance, so just make sure you're familiar with it. For this, I will be using Amazon Linux 2 AMI HVM. It should be the second one here, and it says free tier eligible. Want to make sure it's free tier eligible because we're going to be setting up our Minecraft server for free. And just to be clear, we're going to be using Minecraft Bedrock. It's written in C++. It's a lot more efficient and requires less hardware specs. Java Edition, I know I prefer it, but Java is kind of a not that great programming language for being very efficient. So the minimum specs are actually hosting a Minecraft server with Java are like 4 times. I believe it's 4 gigs of RAM for Java and 1 for Bedrock. So Amazon Linux 2 AMI, that's what I'll be using. Make sure it's x86. And for instance type, we're using Bedrock. Bedrock will work on this. Java will not. I believe if you try to get Java working, you need to use virtual memory and allocate some of that, as well as like if you restart your server, it'll most likely crash. So we're just not going to be doing Java again. T2 Micro is the free tier instance type, and it works great with Bedrock. It's 1 CPU, 1 gig of memory. If you're familiar with any third-party Minecraft hosting, this is very similar to like Aternos or Minehut, just the free tier. But it works great. It's yours. You can configure server properties, so in that way, it actually runs better. But I would say this is good for around 4 people on Bedrock. Just make sure it says free tier eligible. If you want to go ahead and run Java, I recommend tier 2 medium at minimum. Or if you're gonna host with like a bunch of friends, but we're just gonna be using tier 2 micro, T2 micro. To get into our EC2 instance, we're gonna need a key pair for SSHing. So I'm gonna go ahead and click create a new key pair. Our key pair name will be mctest. Why not? We're going to be using RSA and .pem for SSH. If you know how to use PuTTY, PPK, go for it. I'm using SSH, so I'll go ahead and create key pair. And if you see in the top right, it'll download this mctest.pem. This is our private key. Very important. Do not lose this file. You need it for when you SSH in. So after we've created our key pair, you'll see network settings. We're not going to play with network settings for now. And for configuring storage, I would go ahead and just change this to general purpose SSD GP3. It's just better than GP2. I really don't know why GP2 is default. But for memory, or for storage, sorry, I'll just up it to 16 gigs. If you don't have any EBS storage, you can see right here in the bottom right, this like blue box, it says you get 30 gigs for free. 8 gigs is fine. Minecraft servers, especially Bedrock, are not that big. They don't take up much space. I would say like 4 to 6 gigs for like a normal Minecraft server. So long as you're not like loading the entire world at once. But I'm just gonna up it to 16 gig. Why not? And after that, we should be good. Our instance should be good to go. So we'll click launch instance, this orange button at the bottom, to the right, launch instance. And while it's doing that, we'll just wait. After this, it'll say, success, we launched your instance. It'll give your instance ID. And if we scroll down, you can see connect to your instance. If we go ahead and click this, it'll pretty much just take us to a page that tells us a bunch of different ways to connect to our instance. In these tabs, you can see SSH client. That's what we'll be using. So if I go ahead and open up my terminal, I'm using WSL with Ubuntu. If you can see, I'm on Windows. I like to use WSL, so that is what I will be using. So it says open your SSH client, locate your private key file. Mine is in my Windows download folder. I have a symlink to my download folder. But first, I'll just go to the folder that I'm going to be doing this demo in, test MC, and I'm going to move from my downloads folder. I believe I named it mctest.pem, and we'll move it into this directory. So you can see here, I have my private key in this directory. I recommend just making a new directory so that everything's sort of organized. But we see over here, the third step, run this command to make sure your key is not publicly viewable. We'll just copy this, paste, hit enter. That should set the correct permissions for us. And the next thing is connecting to our instance using its public DNS. So we'll copy our public DNS, and it gives an example down here. SSH-I specifies your private key, mctest.pem, and then the default user is ec2-user @ and then we'll paste our public DNS. And if you hit enter, SSH will just be like, hey, we don't see this, and we'll just say yes. And boom, we are in our EC2 instance. I'll make this a little bit bigger. You see Amazon, Linux 2, AMI, or whatever you did. If we go ls, you can see SSH, some bash, some just default files, but there's nothing on this instance right now. So pretty much we're going to ignore the web client for now, and if you're SSH'd into this, I'll maximize it. Hopefully that is big enough. But we're pretty much just going to be going ahead and installing Docker Compose, setting up our Docker Compose script file to pull this, it's ITSG. This person made a Minecraft Bedrock and Minecraft Java server container, and we're just going to be using that to start our Minecraft server. And it keeps it up to date with the most recent version of Minecraft server, which is lovely. But we'll go ahead and type sudo yum install docker -y just for yes. We're just installing Docker. If you want, you can go sudo apt-get, or not on this particular, if you're on Ubuntu, you could do sudo apt-get. You just update the machine. You don't need to. We just started the instance, so just install Docker, and then we are going to get Docker Compose. So this is a lengthy one, but we can see that we completed our installation of Docker. I'm just going to Control L, and we're going to be using curl. The -l is just for if if this link doesn't exist anymore and the server responds with a link to a new location for our link, it will just go ahead and try to download from that new link. Super helpful, but we'll just keep it there. And we're just going to be typing out this very long link to get Docker Compose. uname-m, and uname is just getting stuff about our system or information about our system, and -o is our output. We'll be putting this in user local bin docker compose, so we can use this from our path. And if we go ahead and click enter, you should go ahead and see that it 100% and it did download it. So that is all good for us. And the next thing we'll want to go ahead and do is go with sudo service docker start, just so we can make Docker, or make sure Docker is started. You have to do this or else Docker won't be started and a bunch of issues will occur. But after this, the next thing, we're just going to make sure that we have our EC2 user in the Docker group. Just some user permission configuring. So go ahead and do sudo user mod -a-g docker EC2 user. And these are just a lot of setup commands. Sudo commod chmod, and we're going to give it executable permissions to user local bin docker compose, just so we can make sure that we can actually use our docker compose command. And sudo chk config, oops, typo, chk config docker on, oops, I spelled sudo ordering request and created symlink, perfect. I'm going to Control L again just to clear my screen. And then after that's all fine and dandy, we're just going to make our Minecraft server. I know we're already in a directory, but if you're not in a directory, this is where you'd want to make like your Minecraft server directory for your Docker container. It's just useful to have stuff separated. So I'm going to make directory Minecraft server, and we're going to cd into Minecraft server. And if we see this, we have an empty space to work with. Our private key is in the for our previous directory, and then we're just going to sudo vim into docker compose.yaml. You can use whatever you're used to, vi, vim, nano, emacs, whatever you have. And we're just going to, if you're using our GitHub, you should be copying and pasting a lot of these commands. I'm just hand typing them just so people can follow along. But if you go into insert, we're going to be setting up our Minecraft server. So this is our Docker Compose script. It's using YAML, but we're just going to specify a bunch of things such as the container we want to use, and this it's GSG guy or whatnot. Made this super awesome Minecraft server container. So if you want to use Java, it'll just be Minecraft-server, Minecraft-bedrock -server, and then we're going to be using container name, and our container name will be MC. We'll keep it short. I like to keep these separated, but ports, our ports will be for bedrock, the default is 19132, and it's UDP, so we'll just be using that. Our environment, and this is important, is memory 512 megabytes, and we're going to set our EULA to true. And what these are doing is just specifying like the memory that Minecraft can use, as well as like this is their like agreement. If you don't set this to true, your server will not run or will not start. TTY true. And these are just a bunch of base configuration settings. There's a whole lot to this. If you want to go to this container, they list out a bunch of stuff you can do in your Docker Compose file for like server properties, so like render distance and like other server settings, or you can just edit the file once we pull this Docker container. But stdin open true and restart always, and volumes. Our volumes will be Minecraft /data. There we go. And that should be it for our Docker Compose file. So I kind of messed up the spacing here. Oopsies. Ignore what I just did. I am used to some Emacs commands, but I'm just gonna fix spacing, make it a little bit more standard. Actually, yeah, these should be 1, 2, 1, 2, 1, 2, oops, 1, 2, and 1, 2. So just make it all 4 spaces, and Shift's easy if you're in Vim for a shortcut. Before we actually get our Docker container, we're going to want to do sudo chmod all permissions and on docker.sock. So we're going to go ahead, and one thing I actually forgot is if you include this like Minecraft server header right here is services. And then painstakingly just indent everything. Oops. Just make sure you have services there and go ahead and save. And then Docker Compose up. And so our Minecraft server will be pretty much, it will pull this container, and you should see all of these successes running and wonderful. If we do docker ps, you can see the container and you can see it's up and it's starting all of this wonderfulness. And after this, we should be pretty good to go. If you go ahead and do docker logs fmc, we'll be able to see starting server and everything is made. So now if we want to actually go ahead and connect through Minecraft, we're gonna actually have to go back and go into our EC2 instance and go to instances and security groups. On the left hand side, you'll see network and security groups, and ours, actually it will be easier if I go to instances, and I know I have this terminated one. Just testing some stuff. If we go into our instance right here, and scroll down, and you'll see these tabs. We're going to go to security groups, which is this launch wizard. Click on that, and you'll see inbound rules. We're going to go ahead and edit inbound rules on this right side, and you can see, oh, we can SSH. We're going to add a rule. We're going to do custom UDP port range. We should do 19132. That should work, and we're going to do this to just allow 00000 whatever, to allow anyone from anywhere to access it. If you know people's IPs, you can go ahead and put it in there, but it really doesn't matter. If you're using Java, I believe the port is 25565, and that's TCP, but we're just going to go ahead and save. So we're on Bedrock. So after we've added our connection rules, by going to our instance ID and going to security and security groups, pretty much I forgot one thing. There's one final thing we need to do. If we go back to our CLI on our EC2 instance, ls, you can see here, right here, there's our docker compose YAML file. If we go ahead and sudo vim docker compose.yaml back into this, right here on ports where it says 19132 19132, add a /UDP. We just need to specify that this is a UDP port. For whatever reason, by default, I think it sets it as a TCP port, which does not allow you to connect to the Bedrock server for whatever reason, or, well, that's the reason. So if you go ahead and add this /UDP at the end of ports, save, and just to be safe, we're going to go ahead and do docker stop MC, that's our container name, and then docker compose up-d to start it again. You should see that says container MC started, excuse me, and we'll go docker logs -f MC to see the logs, and you'll see I was doing some testing because I forgot about that, but you'll go ahead and see starting server, all of this good to go, and IPv4 supported port 19132. Our server started, so we can go ahead and open up our Minecraft launcher. And again, we're using Bedrock Edition, so once this gets started, we're going to use Minecraft for Windows or whatever it is called. Yep, Minecraft for Windows, latest release, and we'll go ahead and click play. And then after this is all loaded, we should be able to connect. So one thing you'll need is, as this is loading, go back to your EC2 instances, go to your instance ID, and then go to this public IPv4 address, and we're going to copy that. This is what we'll be using as our server IP to connect. And if we go back to Minecraft, just exit out of that event, we'll go to play, servers, add server, just do demo and server address, copy paste that public IPv4 address for your EC2 instance, hit save. And I've already added the server. It's called MC demo, but here is the server address for mine. You can go ahead there, and you should see it says online current ping, and go ahead and click join server. Say locating server, and boom, we are in our Minecraft server. Sorry if that's a bit jarring. But boom, you can destroy blocks. You can see it is not entirely laggy. This is more so my recording software is lagging and my game is lagging, but we're in a Minecraft server. I'm just gonna go ahead and save and quit because my computer does not like me recording this and doing Minecraft. I'm on a laptop right now, so that's why. But yeah, that's how you connect to your Minecraft server. So if we go ahead and close that, one final thing that I do want to show you is if we go to our terminal, and I'm going to Control L, and we'll go to Minecraft data. You can see all of these sort of files. There's an allow list and a bunch of other stuff with our container. You can see the worlds pack and whatnot. But this server properties, if we go sudo vim server.properties, you can see all of your custom server settings. So server name, you can change that. Game mode, you can set to creative, adventure, force game mode, difficulty, easy, allow cheats, max players, all of this good stuff. Especially with like your view distance, so that you can make the server not lag when everybody's loading in a bunch of chunks. But you can go ahead and edit any of these server properties. As you can see, all this blue text explains each property. It's more so a thing to do with Minecraft. But that will be it for this demo. Again, thank you all for coming to our final AWS workshop, and hopefully this helps you out in some way. Maybe it sort of solidifies what a server is and how you can use AWS to host a server of some sort, in this case a Minecraft server. But yeah, thank you all for coming, and see you sometime later, maybe next year, but yeah, thank you.